Okay, I tried to start the recording,
Yeah.
but I don't have much space on my hard drive. I think maybe, let's see.
I could set up the stream here.
No, it's okay. Let's try to record, and I will try to upload this later. It's clear, right? So now we have then x is what is it? Maybe I can you follow so far? I'm a bit fast, right? I'm not too fast. Yeah. Okay. So let's rename it. Let's use capital X. Let's use capital X for the list and small x for the element. Okay, that makes it a bit easier to read because we need a y, right? Okay. So now we want to basically store this data in, well, let's make it more interesting, right? Let's say x to the power of 2. And now we want to store the data, right? Because here we are just printing. What we could do is we could create a new list and store the elements in the list. That's what you would do probably in Java also. I don't know. So the straightforward way would be to have a list y, and we would append x to the power of 2, right? But this doesn't work. Why is this the case? Why? Yeah, but we learned that we don't need to give types, right? But you are right. Look at this. Because we are calling a function from a variable or from a class which is unknown. Python cannot guess it. Which append do you mean? What should it be? We have to say, y is a list. And then you can use this append. Because Python cannot guess. If I say x is 5 dot or k is 3, it knows, it can guess, right? But here it's impossible. It's a complex class with an append method in it, right? So what you have to do is very simple. Trivially, you just say y is an empty list. Right? And then you're executing it, and then you can call your y, and here you have it. Okay? Hi. There is also some seats here if you like. You want to sit? You can also, there is in the corner if you like, if you want, I don't know. But you cannot see well, right, from there. Oh yeah, but it's about the screen. Don't you like to join over there, maybe? Okay, it's okay. 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 So now we have x, right, and we have y, and we want to print them side by side. That's basically the first thing you would do, right? So we saw that we can use this for loop, right? And but now we have to access two lists at the same time, but we are glad because the lists have the same length, which means what we now do is we zip x and y. You know, a zipper, a zip, x, y, zip. And this is now a combined list, you can say. And you have basically two elements now, x and y, right? Because you have the zipped list side by side, and you are accessing it now in one go. 4xy in the zip of that means the first pair, the second pair, the third pair. And we can just print, of course. Let's say print, let's say x colon y. No, x comma, quotation marks. You can use single or double quotes. Python is very relaxed. So you can use single quotes or double quotes, right? In zip, of course, sorry. And maybe let's add another number. Let's add here a 40. And let's do the calculation again, right? You just run through the code and execute it again. So I want the 1,600 here, right? But the only thing I did is I added here the number 40. And then I execute the cells again. Shift, enter, 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 and then you run through the code again, right? And now I have my 1,600. And when you use the simple printing, right, this one here, it's ugly. It's not aligned, right? You see, because the numbers have different lengths, it's not nice. In Java and also, of course, in C, you have a formatted printing, printf. And this is also true for Python. Now, this is a bit, you have to get used to it. So first of all, you say you need a format string, and you say, I want to print the number x, and I want to print the variable y in curly braces. Can you see that? Let me zoom in a bit more. Curly braces. Right? That would do the job almost. But this is a simple string, right? How do we tell? It does the job, right? You see, that's what we want to print. In fact, we don't want to print that, right? But now we have to put in Python, you have string modifiers. It's a bit weird. You add a little f in front, which tells the system, hey, this is a format string. It's not just a string to be printed. Please interpret this as a formatted string, a format string. You just add the f, and then you get it. But you see it's still pretty ugly, not aligned. So let's start with the right side. So now we can add format modifiers. We say this is an integer. D stands for decimal. It's a decimal. X is printed as a decimal, and it should use, I don't know, let's say 3 digits. So 3 digits are reserved for printing, and then it is right aligned. And now we have the left numbers here nicely aligned, right aligned. And now we do the same on the right side. What would I have to do to achieve the same here? 40. 40. Say it again? 40. Yeah, okay. Let's try. Very good, right? And then we can say from x to, or yields, right, or this. So x is equal to yields y is equal to, right? Nice. It's cool, right? Yeah. And maybe you want here another blank. You can say, okay, I reserve 5. Whatsoever, right? You can do whatever you want. It's so powerful. Maybe here another, I don't know. X is 0, yields y is, and so on. Good. But, as I told you, right, for math, it's not suited. We need another data structure to do that. And this is NumPy. Oop. So what we have to do now is we have to import NumPy, numerical Python, as NP. NP is just an alias, right? So we are too lazy to always call the functions numpy dot. We just want np dot, right? So we import NumPy, the whole module or library, you name it, and we rename it as NP, right? That's what we do. What? This is a catastrophe. Yeah, but I thought that Jupyter Lab would include NumPy. Okay, so that means I saved my code. And there is a library missing, which is super important.
have internet. The UNICES is not working fine right now. So
Do you have
I would
internet?
suggest-
Huh?
I would suggest to.
Don't we have? Also, we don't have internet. So we use the base
Yeah,
installation.
I would suggest. to
Okay.
do this installation.
Restarting the router
Okay.
to see if it works.
Yeah. Okay. The fallback is basically we use the base installation without the environment. We can do that as
It's
well.
ugly, but for the purpose of the classes,
Yeah.
it's going to be okay.
Yeah, I think it's okay. So that means save your work, right? Save, close the browser, kill. Now you go back to the command line here, Control C, right, and then you kill the kernel. By the way, now we can look what happened in the background, right? So here we started basically Jupyter Lab, then some notebook classics and so on. And here the Jupyter server started, right, at localhost 8888. There is a web server running in the background which executes the Python code. That's basically the Jupyter server, right? And so basically, that's not correct. Localhost 8888 is your web application which gives you the Jupyter notebook in the browser. This web application also provides a link to a kernel which is running as another server in the background. There's another kernel. Anyway, so now let's.
You have internet now.
You have internet?
Yeah.
Okay, that's good. Anyway, it's good that we closed it. Now we have to install a few more things. I hope you are still in the UNICAES environment. Yeah? Now we say conda, install, -C. Be sure that you are now in this UNICAES environment. We want to install the software here and nowhere else, right? Install -C conda forge, conda-forge, and SciPy. SciPy.
Everybody install, for example, scikit-learn directly.
Oh, scikit-learn.
Is what to use it.
Oh yes, sklearn. Do you think that?
It includes NumPy.
Yeah.
Yeah, yeah.
And pandas? Does it include pandas?
I think so. But it was not
Okay. sklearn. sklearn is another very heavy meta package for machine learning, and we will do a machine learning example later. SK stands for scikit, scikit-learn. It's for machine learning. Conda forge, scikit-learn, right? Conda install -C conda forge, scikit-learn. So I thought that Jupyter Lab would include NumPy, but it didn't. Yep. Yeah, you should close the browser and just go back to your terminal and then Control C until the server stops.
Anyway, the server ends the connection when you make the Control C.
Yeah, but then you get the errors in the yeah, you're right. Yeah, you're right. Absolutely. Fade Vision ist a frozen solved. Das ist echt scheiße. Scikit-learn ist aber in der Standardinstallation dabei, oder?
Scikit-learn ist keine Standardbindung.
Ne? Fade Vision.
Aber wir können jetzt mal mit dem Base anfangen. Doch, die Base hat Scikit-learn. Doch.
Yeah?
Doch. Ja, die Base hat folgende Sachen.
Okay, so I stopped the installation. Let's stop the installation, right? I think it is. Is it running with you, for you, the installation? Yeah? I have here an issue, which I don't know why. You see, there is. It seems there is a. Ooh. Okay, it seems that that's the
HTTP.
it's the
Connection.
DNS.
That's the DNS program.
It's the DNS. Okay, let me try again. Maybe I would have no. Maybe I have to restart my Wi-Fi, close and open again or so.
I tried it. I think it's just a matter of the saturation of the server.
Saturation of the server?
The router is
The
saturated.
router. Okay. For me it's not working. If it's working for you, it's good. So for whom is it working? They're still connecting.
I think problem with you, that problem solved the time.
You can work with the base
Yeah.
and see how much we
Yeah,
can do.
Okay. So I think let's interrupt the installation and we use the base installation. So which means not here, but the base installation. Okay? Because it doesn't work. So what we have to do is we have to exit. Is that correct? To leave, right?
To leave what? This? No.
I just want to leave the environment.
Again, Conda?
No, that's too much.
Deactivate.
Deactivate, of course. Yes, you're right.
Or you can activate again the base.
No, sorry, that's wrong. What's this? Here. Now I have to change the directory again. Anyway.
I think the problem is the network.
Yeah, it can be, yeah. But we have a workaround. So now I use here the base. So when you are in your environment, just say conda deactivate. Conda deactivate and then probably UNICAES or so. Okay? And then you should come back to the space environment. Does that work? Okay. Can we go on? So now I start Jupyter Lab in the base environment, right? So I left my sandbox and went to the base installation, which is another environment. But usually I avoid to work in base because when you crash something here, you maybe have to reinstall the Jupyter environment. Anyway, it's not important. So I just start Jupyter Lab again. And you see here in the browser, in the browser address, right? It connects to localhost 8888. There your web application is running. And the web application is basically giving you these sets. By the way, I didn't tell you much about it, right? How to use it. We now import NumPy as MP. Now it's there. Okay. So what is nice about this? I didn't tell you much, right, about this environment. First of all, you have cells, and these cells can have different types, right? A cell can be a code cell, a markdown cell, or a raw cell. And of course, the standard cell is a code cell. Otherwise, oh yes, I would have to run everything again. And if I want to run everything again, I simply say run everything. Run, where is it? Run. Run all cells, right. Now it's executing all the cells. Okay, and so you are here in this edit mode, right? And you can edit the cell. When you click outside the cell, you are in this, control mode. And here, for example, you can move the cells around, right? You can move the cells if you like, and you can also change the type of the cell. You can also add cells. Okay. So, for example, when you are in this control mode and you press A, then you are adding cells to the top of the current cell. If you press B, you are adding cells below the current cell. DD deletes them. Right? Okay, here I would add a B. Sometimes you need cells in between or so, right? DD in the command mode. DD, DD, 2 times DD. So A adds a cell on top. So when I'm here, right, I'm in the command, in the control mode, cell control mode, and I press an A, I add another cell on top of the one. A, right, that creates a new one, and with double D, DD, I delete it again. Okay, but you can also do it with the drop-down menus, you add edit, all the, and here you see also the shortcuts, cut cell, copy, and so on. Okay, so now let's make it a markdown cell. Okay, did I lose you? Is it, do you need some time to solve some problems or so? What about the girls? Are you still alive? Are you sharing the same computer or what? Oh, great. I think we'll wait, right?
No, solo tiene que estar dentro de todo el archivo, solo dentro de la carpeta nada más. No es necesario que se meta en la dirección.
You can speak Spanish. So we are so used to English in our classes. If you need a break, we can have a break if you want, right? You can also leave and come back, so.
If that's your, if this is a Python file, then you have the code which is in this Python file image. So it's like uncalled application. Yes, yes.
Carlos, it's okay, right? I want to slow down a bit so that they can catch up. Yeah. But now comes the very cool stuff.
Linux installation.
Right. Apt-get install.
Pero no sé si trabajamos descargado y puede descargar para porque ese error que estaba dando y por eso le entrego la herramienta para descargar la receta del disco. Pero como estaba haciendo el problema, no la descargamos, no se acabó.
No, that's fine. That's fine. Claim, can I go on? Do you think you can solve it there? Or?
It will take time, so yes.
Huh?
This will take some time, because it's a problem in installation.
Ah, okay. Okay. Can I go on?
Yes.
Okay, good. So, now before we start with the cool NumPy, I would like to show you the beauty of the markdown cells. So, let's go to the very first cell, right? Click on the left of the cell and press A to add another cell. And now change the cell to Markdown. You could use either here Markdown, or you press M when you're in front of the cell. You see that this execution counter here vanishes. And now, I don't know, are you familiar with Git repositories? Have you used Git software? GitHub, GitLab, Git? Yeah, and README, the Markdown files. You know the Markdown? Okay, so Markdown it's a joke, the name, right? It's basically a markup language like HTML, but very reduced and much easier. You cannot do much with it, but what you can do is awesome. For example, you start with a new heading and you use a hash mark and say, this is my workshop. UNICAES workshop. UNICAES workshop, right? And then when you execute the cell, you have a nice typeset. And then we add maybe another cell here, where we say M tick tick about types, right? And you see, since I used here 2 of these hash marks, it uses the next heading. So it's you know HTML, right? Do you know HTML? Header H1, header H2, header H3. This is header H1, H2, H3, and so on. And you get it by about types, and this is maybe third level and so on, right? Third level. You see, this now gives different. So what else can you do? You can have bullet lists, item 1, right, and item 2, right? You have item 1 and item 2 as bullet lists. It's a bit noisy. Does it mean I lost you, or what's the problem?
What is the command to execute this?
To do what?
To execute.
You can execute the cell with a.
Can we execute?
So no. That's what I said. It's still a code cell. This has to be a markdown cell.
Oh.
No, execute it. So this is the beauty, right? You have cells and they're independent. You can say, this is a raw cell. I don't want this to do anything. I use a markdown cell for printing and describing things I'm doing. or use a code cell in Python to execute Python code. So that allows you really to mix code execution and explanation, description, and development of your own thoughts. And I don't know, do you know about LaTeX? Have you ever used LaTeX? LaTeX. LaTeX is this. Oh, it's wrong. What's the mistake here? I don't know what the problem is. It's capital T, of course. LaTeX. LaTeX. Don't you know that? When you want to become a scientist, you need LaTeX, right? Because what it can do is you can typeset formulas without this, sorry to say that, this bloody Microsoft formula editor, right? It's a nightmare. But to be honest, also Microsoft formula editor can also understand some of the LaTeX commands when you type them in Word. I don't know if you've seen that. Anyway, you can, for example, say, I want to type, it's for mathematical typesetting. You can say, okay, I want to print an integral, right? I want this integral sign. You say integral from lower limit 0 to upper limit infinity. So the commands are in LaTeX are introduced with backslash. So this is an integral, lower limit, upper limit of the exponential function e to the power of x, e to the power of negative x is 1. Is it cool or cool? No, it's none of that. It's super cool. And you can add this stuff even in the decoration of your plots, which means we will create plots, right? Mathematical graphs, and you can enrich even the graph with formulas, right? You can rotate it by 90 degrees and plot it on the y-axis, right? It's fantastic. Learn it. And this is a kind of LaTeX, to be honest. And what is used in the background is called MathJax. And that's based on, it's basically MathJax. LaTeX, it's a kind of similar language, right? You can create nice, for example, indices, right? Very nice. You can read it, right? Let's say x index k is 3 or something, right? Then it's very nicely typeset, right? Okay. Good, so this is Markdown, right? And now we start here with the import NumPy, right? And here I add another Markdown cell and say NumPy. Just for myself, oops. Because this sometimes also helps you when you have a very long text, right? And you're searching for, where was it? Oh, here's my NumPy. Here I start with my NumPy, right? It helps you also to browse through your documents. So now, the cool thing starts. We want a vector x. So everything in NumPy is the most fundamental data type is an array. And we make it now an array. And this is a constructor of an array that creates an array. So I'm calling the method array from NumPy. And I can pass now a list. For example, the list we had before, which is x. Right? The capital X, it's still there, right? The capital X is still the list we had. Right? And now I have my lowercase x. What is that? Oh, it's an array. What is the type? It's a NumPy ND array. Okay, and this is a very particular, very special data type because it's basically this. And it allows for implicit parallelization. It's a kind of hyperfunction. What it means is, you remember, right, what we wanted to do is basically, we want to execute x to the power of 2. So let's do it. X to the power of 2. That's it. Which is basically a kind of mapping, right? What is done implicitly is, in the background, of course, there is an access to each element, and this function here is applied to each element. Okay, wow, and now we save it, right? This is now y is x to the power of 2. And if I have my y, it looks like this. And I can do some cool stuff with it, and we come to it. Now, let's say, this is one way of creating an array, right? Another way of creating an array is, I want to use a range. A range, I don't know what this A is for. A range. And then you give a start value, let's say from 0 to, let's say, 10. Oh, okay, that's also interesting. Let's start with this first, right? What you see now here, when I do it like this, so this is important now to understand. It's a bit weird. I don't know how this is in Java, but when I create such a range, you see, first of all, if I use integer numbers here, right, without a dot, Python assumes it's an integer, not a float. You see this also in the results. There's no comma, no decimal comma, no dot. And the upper limit is not included. You see, it goes up to, but not including 10. So when you want to include 10, you could add a little bit to it, right? Then it goes up to, let's say, 10.0001, but not including it. That means the last number, of course, is then included. And now you see it changes. The dot indicates it's now a float. Because I'm using a float here, it has to be a float. And it goes up to 10. I say, I would like to increase the density of the numbers, right? Maybe I want more than just these. I want, let's say, half values in between. Then I give a step size. And the step size is this, right? I just say 0.5, 0.5 or 0.5, right? And also here I could say 0.0, of course, or 0 dot. So there's other ways, right? And let's say x. What do you think is the size of x now? What's the length of x?
It's like
Hmm?
it's like
21. Very good. Because the upper limit is included. And x has a shape. 21 in one dimension and none in another dimension. Which means, in the same way, we can create matrices. And we can come to it a little later. So now guess, right? Now I can say y is x to the power of 2. And I want to know what y is, right? So y. And now you can imagine, right? I want more numbers. I want 1,000 numbers. I want to go to 1 million, or I don't know. I want to change the sizes between the numbers. Great. What do we do with it, right? Of course, we want to plot. This is now a bit freaky. This is something which is a bit ugly, I think, but you basically have to learn it by heart. Yeah, this is really a bit weird. We need now a plotting function, a plotting package. The standard plotting library in Python is matplotlib. And we are importing now, import matplotlib, and from the mat, that's a very powerful package. There is a sub-package, a sub-module called pyplot SPLT. This is pretty much a standard. You find thousands of examples of Python code using matplotlib, and they always start like this. Import matplotlib pyplot SPLT. That's pretty much a standard. That's what you import NumPy, you import matplotlib. That's what you're doing from the beginning. Okay, now there are so many different examples for plotting libraries, and I will give you another example in one of the other. It's a bit old-fashioned, to be honest. Matplotlib is pretty old-fashioned, but it's still a working horse. It's still cool. For many purposes, you have to know it, right? When you want to have a fast look at data, matplotlib is definitely the way to go. Now we have to create a figure. Let's say figure 1 and axis 1. Now we are calling from PLT subplots. And I want, so we are calling from PLT subplots, for example, how can I explain that? I just do it. Subplots. And what this does now is, it creates a canvas. This canvas here, or this already, that is called the axis. But the axis, this is x1. x1 is this frame. In fact, it is the whole object. You can have more than one. For example, you can say, I have figure 1 and x1. So this, when I use the brackets, instead of the square brackets, the parentheses, the round brackets, it's a tuple, which is a list which is immutable. I cannot change it, right? But let's say we have x1, x2, x3, and x4. And we want to plot 2 by 2 plots. And I have a mistake here, and I don't know why. Expected 4. What's wrong? Is it like this? No, it's not. Expect 5 got 2. Anyway, there's a small mistake, but you see the idea, right? x1, x2, x3, x4. AX, right? X is 1, X is 2, X is 3, X is 4. This is an axis. That's the naming. And this is the figure. The figure is the whole thing. If you just call the subplots without any size, or let's say number of rows or number of columns, you just get the trivial one plot. And here you can also change the figure size, right? For example, here you can say, for example, let me go back to my original size in my browser. Then it looks like this, right? When I do not zoom in. And here I can say figure size is equal to, let's say, 8 and 6. In arbitrary units, it should be hinged, but it's very confusing. I've never found out how this really works. And I use a DPI, dots per inch, 150 or so. But with this, what I wanted to show you is with figure size and DPI, these are two parameters with which you can tweak the size of your figure. You have to play with it a little bit, right? If you think, oh, the figure is too small, change the figure size. Anyway, so I think our comments. Comment is just a leading hash mark. So I make this a comment because I don't want to lose it, but I will go for the standard, and of course here I forgot x. x1. Okay, x1. And I use now just fig and axis as subplots, right, like this. Okay, good. I can zoom in again. right? So maybe this is a bit exaggerated, but this, right? So, okay, now let's plot. Where do we plot? We plot on the axis. The axis is one of the subplots, right? And then you can choose, I want to plot in axis 4, which is the lower right corner, or axis 3, which is here, and so on, right? You can create great, let's say, matrices of plots. And we plot. And what do we want to plot? X and Y, of course, right? That's it. Ta-da. Then I get a message here, X and Y. And let's start with another X, right? Let's go for the cause X. Let's say from 0 to 5 or so, right? Just 6 points. So I change it here, right? From 0 to 5. So the default step size is 1, right? When I omit the step size in the A range, I get just a step 1. Okay. Then you see here, of course, the kinks, right? And I can change also the plot style and say, you know, my favorite color is red. So I use just red. And I want to plot symbols. Or no, I want to plot symbols and lines. And I want a grid. I get a grid. And I want some axis decorations. X label. X label X. Right? And by the way, here is a final, this is a message which is basically the final output of the command. To omit this, I use plt.plot. This simply suppresses this last message here. So I have an X now, right?
Dot show is better, isn't it?
Hmm?
Dot show is better.
Say it again?
Dot show is better because also suppresses the brackets.
PLT dot
Show.
show, of course, not plot. Sorry, that was my mistake. It's show, not plot. You're right. Right, that was my mistake. Yeah, right. So I have an X. But you see, this X is the standard type writing, and I can also add mathematical interpretation and say, okay, I have an X, right? But to compare the mathematical typesetting of an X, I use this $x$, which says it's a formula. And maybe you see there's a slight difference here between these two numbers. But I can also say, okay, my integral, right? Integral 0 to whatever, infinity. And you can also do this for y. Okay, y. And then the integral is even rotated. Okay, doesn't make sense, of course, now, right? But it's clear. And then you have labels. You can say here is a, what is that again? Label is my x or something, right? My function. And then I need a legend. Right, and then I get my function. But I can also add maybe another function, right? You can say, if I add another plot, I say I want to maybe plot y plus 3, maybe in blue. And here I say maybe this is y plus 3. And this is maybe just y. Right? Forget Excel. forget it. With a hotel model, you can use this with Excel. Because of course, you can even remote control Excel. Instead of using Visual Basic for applications, you can even use some Python code to control Excel. Of course, you can exchange data. It can read CSV files, it can read Excel files, and so on, right? Good, so now I would like to show you a few, to speed up a bit, I would like to show you some examples. Please open, which one? The IPy widget is maybe not installed. I don't know.
I think it's better to start with CS231. Like quickly go through it.
No. Oh, you mean because of matrices and all this stuff?
Yeah. Or should we just keep that and just explain it?
I would like to go on with basically with plotting.
Okay, then.
The integral. I don't know. There is one. This function interactive parabola plot with integral and so on, right? This is one program which so you see, this is now really a tutorial for my students, right? The discussion on how to create new functions from old functions is inspired by the math book Calculus by Niels Stewart. I don't know if you know this math book. It's an English math book, Calculus. Fantastic. So, right, and this notebook allows interactive modifications of a parabola in the so-called vertex form. This is a parabola, right, in the vertex form. Right? X0 and Y0 are the coordinates of the vertex. Okay, two parameters X0 and Y0 determine the position of the parabola's extremum, maximum or minimum, right? The parameter C stretches or compresses the parabola and determines if the curve is concave up or concave down. This notebook also introduces interactive plots based on Matplotlib, and here the trick is interactive. Therefore, you need the so-called IPy widgets. I'm not sure if they are in the space environment. Maybe you would have to install them later. Conda install IPy widgets. And I'm using numerical integration. Trapezoid rule.
Can you run the cell again? So that it looks better?
Sorry?
Can you run the cell again?
Oh. NumPy trapezoid is a numerical integration based on the trapezoid rule. Do you know the trapezoid rule? Probably yes, right? Okay. Furthermore, LaTeX, aka MathJax, strings for pretty math formula rendering are used in the plot. The plot title shows the actual quadratic formula of the parabola and vertex form. Okay, so what I'm doing, as I said, right, NumPy SMP, Matplotlib, Python SPLT, and I need now interactive widgets because I want to use sliders to modify my plot. So when I'm defining my function, I define the function f of x with parameters x0, y0, and c. And here these are default values. When I don't insert a value here when I call the function, then the defaults are used. So I could call the function f of x, or I could call the function f of x with x0 is 5 and y0 is 2. Both would work. So with these values here, I get default values. I can override them, but if I don't use them, it uses just the defaults. I can give you an example. So you see the standard values are c is 1, x0 is 0, y0 is 0, so we have f of x is x to the power of 2, right? So let's see what that is. I need an x. You already know how that works, right? MP A range, let's say from 0, A range, my goodness. A range, let's say from 0 to 5, right? That's good enough to demonstrate. And P is not defined, I forgot to execute the first cell. Okay, now I have an X, right? I have an X. and now this function is known, I can now call f of x, which is now 0 to the power of 2, 1 to the power of 2, 2 to the power of 2, and so on. Or I add maybe here a constant, right? So then I can say y0 is 100. Right? So I'm just adding now this y0 to it. So that the beautiful thing is, you can define default values, and the formula has a default behavior. Okay, so create the plot title, mathjack string to render. So that was quite difficult, right? Because I wanted to basically, in the title, I wanted this string together with the values. If c is 1, a 1 should occur. If x0 is 5, -5 should occur, and so on, right? And what I want is basically this. So full rendering, so if c is 0.5, the string should look like 0.5 x minus 2 to the power of 2 plus 0, right? But when this is 0, I don't want to write x minus 0, I want to omit it, right? So that I have 0.5 x squared plus 2, and I want to remove c if c is 1. Okay, so let's execute it further. And here you can see now, I created a function myTitle, which basically does the different cases, right? If this is that, and that, and that, and so on. And here you see the results. F of x is constant 2, x squared plus 2, 0.5, x to the power of 2 plus 2, and so on, right? With the different parameters. So what is the result? Here I'm basically defining the integrals. And now I have my interactive plot. So you see, standard is 0.5 x squared, and the integral is this one. Integral from 0 to 3 f of x dx is 4.5. And now I can change the c.
You can teach calculus with that.
Yes, of course. Of course. You see? Look at this. And it changes the integral.
Then you learn programming, math, and everything at the same time.
Right, you can see how y0, so I can move the vertex around, I can make c negative, I can change the integral, right? I can make it even steeper, so right? And you get the result here, interactive plots. Do that in Java. It's of course somehow working, but it's a nightmare, I assume. This is easy peasy. Okay.
Not fair.
No, Java is a good language.
No, I mean, I had to learn how to do that by hand.
Yeah. Yes, of course, and this is used before you show this. You train the students to do the manually, of course. So you can study the code. I just want to give you a few examples. I feel that people are getting tired. And so I would say, I show you a few examples and then we stop, okay? But just to give you an idea. So another super cool example is, we haven't talked about pandas, but I can show it in this. That's another one. Oh, this is also cool. Pandas produces data frames which are similar to spreadsheets in Excel. So you have So that's the next super cool thing. It's extremely powerful. It's pandas. And basically, this comprises NumPy. So NumPy is a part of pandas. What pandas provides you is a spreadsheet. It's called a data frame. This has rows and columns. And each column has a name. Each row has an index. It can be arbitrary indices, can be a time series or whatsoever. And each column here is a series. So this block here, that's an ND array. So the numbers which are here, right? This is a two-dimensional NumPy array. But you have these columns and rows, and it makes the interaction with this data structure much easier. I will give you an example. I think I don't. It's too much. I'll show you maybe the asset iteration here. This is, so my students are from the study program Environment and Energy. Control. And one of my students is Ziad. He's from Lebanon. And he's almost 30 years old, I think. He even ran his own business in Beirut, but because of this deteriorating economy, he left his country. And he came to us, and he's a wonderful oud player, you know, this guitar, this lute, this African, Arabian kind of guitar. Wonderful, and he's a beautiful singer. And he even teaches it. It's really fantastic. And he's a very smart guy, because he's very straightforward, he knows what he wants. Anyway, he told me we did this scientific programming stuff. And he was so sick of chemistry and said, oh, I hate chemistry. I don't want to go to the lab and do this bloody titration. And then he asked me, Professor Becker, I need to draw this diagram. Can't we do this in Python? I said, of course we can do it in Python. We can do everything in Python, right? And then that was a weekend, right? We had a discussion forth and back. And and this is the result, right? It was inspired by him. And so one experiment in our university chemistry lab is the titration of sodium hydroxide, right, into acidic solutions, acetic acid, CH3COOH, or hydrochloric acid HCl, right? And I don't know if you know titration. Do you know that? Do you know what titration basically is? So you're adding drops of one substance to another substance. And sometimes you have this pH value. Maybe you know it, right? You have the sour and the acidic, the acidic side, and then the hydroxide side. So pH, the higher values, the lower values are sour, and the higher values are forgotten. And then you can measure the pH, and at some point, when you do this experiment, so you have maybe here you can see that we are such as we have HCl, for example, it's a strong acid, and then you are adding this hydroxide to it, sodium hydroxide, drop by drop by drop, then you are measuring the pH, and at some point, it completely flips. The pH suddenly changes completely, very steep. And in the end, I can show you the diagram. In the end, it looks like this. So you have here the sodium hydroxide, which you're adding to the acid, and then you see the pH here, right? Sour, 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 still acidic, right? It's still very, very low. It's a very strong acid still, and then at some point, poof.
The reaction occurs.
Yeah, and then it really switches its characteristics, and the pH now gets 12, and then basically the NaOH wins. Here the acid wins, and here the sodium hydroxide wins, the pH of the mixture. And what the students, so these points here are measurements in the lab. And what they have to do is, they have to basically draw a line here. They have to draw manually, right? They do it in Excel or in paper. you take a ruler, you draw a line here. You take a ruler, you draw a line here. Then you take the point of the steepest ascent here, and you draw a line here. And then you get a cross point here and a cross point here. And then you take the middle of these 2 points, right? It's basically a line. And then you are adding up here, and then you say this is the turning point. And you want to know where this happens here. Okay. So what we did. So first of all, I got his data. You find the data hopefully also here. It's the CSV file. And you can see data by Ziad, right? And the NaOH in milliliter and the pH. And that's, of course, you could also open this file in Excel if you like, right? Or in an editor. Usually, I highly recommend whatever data you get, I highly recommend Linux. Yes, of course. Of course. I highly recommend to use editors to have a look at your data. You usually get that this is now, that is produced by Ziad, right? But sometimes you get data from somewhere else. And you should have a look at it first. Are there missing values? Is the data clean? What are the units? What is the separator? Sometimes you have semicolons. In Germany, we have this crazy idea of using a comma as a decimal separator that kills you. Sometimes when you have a Excel or a CSV file stored in the German language adaptation, you have a comma here. You know what nightmare that is? Because you cannot distinguish, is this a decimal separator or is it a field separator? And everything crashes. So I tell the students, don't use the German standards, right? Use international standards. Anyway. Okay, you can use that in Excel, of course. You can use OpenOffice or LibreOffice or whatsoever. And you can use Python. And I give you an example here. Which one was it? This one, right? Acidic. And the CSV, so Control B. So you see how nice this is, right? Here I described really, no? One exercise of this practical experiment is to determine the middle point of the steep rising edge. At which concentration of NaOH does it happen, and at which pH value, does it happen at which width? This is a typo, and which, right? And then can I correct it?
Yeah.
Which pH value? Middle. Of the edge, right? And I can publish it with my students, write the update. Okay, so the first task was to learn linear regression, because you have to draw a line. And so here I'm using a linear from the linear algebra pack, the least square method to create a linear regression. There are so many ways, but I use this one. So then write data to CSV file, because at the beginning, Ziad added all his data in the notebook, but I said, why don't you store that in a CSV, then you can share it with others, right? So now we can read it. You can say, okay, the final name is the HCl titration. I think I have to run through the code, right? So I execute this, go on, and here file name, the title, and the figure name. And then I just say numpy load text file. Delimiter, comma, comment is a hash. So that means it ignores all hash marks. The delimiter is a comma, not a semicolon. And then I have my x and y. That's it, right? X is there. And y is there. Good, so let's list the values. And you did it before, right? Print formatted, you know, now side by side, concentration of NaOH and the pH value. And then we plot. First of all, what I always do is I just have a first guess. Let's see how the data looks like. Open an editor before you analyze the data, look at it, read, and then use Python, and then plot. And now the stuff is missing, right? And then we said, okay, linear regression, and how does that work, and the crossings, and in the end we have the final plot, and that looks like this. Oops. Control 0. And everything is dynamic. The only thing I do is I tell the system how many points I want to use for the linear regression. And here as well. And the rest is done automatically. It determines here the first derivative of the curve. It determines the steepest edge. It determines the crossings of the two lines, here and here. It determines the midpoint of these 2 points, which is here. And then it automatically also writes here the concentration and the pH. And when I change the data, it will automatically do the stuff. So this is not hard-coded. It's dynamic. When I change the data, I get the new graph. Okay, so now a final example, and I think that it's really enough, right? But we have them on there. When you want to play with it, read the code, it's on your workshop folder. This is a fantastic work of students of mine, and they are not data scientists, right? They are kind of natural scientists, and this is a typical machine learning problem. Maybe you know, of course you probably know that this plant here, right, papava. It's a poppy in English. And this now is a somniferum. It's where you get the opium from. And my friend and colleague, Daniela Luth, she is ecologist, and she has a class on basically classification, to learn to classify vegetation. Environmental assessment or something, I forgot. Ecology class. And then you have here the 4 species of papava, poppy, right? And this one here is papava somniferum. This one here is orientale. This is dubium, and this is voyas. And you see that the capsules are very different. And as a human, you can easily distinguish. But the question is, how can a machine learn? And then you determine some parameters, right? You say, okay, I measure the cap diameter, I measure the capsule length, I measure the capsule width, and the stalk thickness. So the stem, right? The stalk thickness. So 4 features, 4 parameters. Thickness, the width, the diameter basically. So thickness, diameter. No, this is thickness, this is diameter, width, no, this diameter. Oh, sorry. So length, D, L, W, and T, right? So diameter is that of the cap. The length, the width, that's the width, and then we have the thickness here. And then the students created this fantastic data set. This is very cool. And it's this poppy capsule class data. And so here you see different sets, a species number, a species name, then the capsule length, the capsule width, the ratio length to width, mean values, some derived values you have here, right? But the most fundamental are basically the length of the capsule, the width of the capsule, and then I have somewhere the cap diameter, and the stalk thickness of the stem. So we have a lot of features in that data set. And now the question is, do we find a combination of these features? I give you the numbers and you tell me which poppy species it is. Do we find an algorithm, a method, a rule that when I give you the width, the length, the thickness, and the diameter, that you tell me which variety this is? Or is there a way to combine the numbers such that we can automatically determine the species of the poppy? This is a classical machine learning classification problem. So you have properties, features, and you want to predict which class this feature, basically, the feature set, points to. Which of the poppies is it? And now that's really the big beauty of Python. So and again, right, this is, you can, here, this is again, Markdown code, and I added here the figures and the images as HTML, right? Because that allows me to also modify the width of the images and so on, right? And I can even add here links, right? This is the syntax for a link. So you can add your own links to the text, right? Cool. So now we are using pandas. And here I just say, read the CSV file. So I'm using pandas read CSV. This is the data file. I want to skip the first 4 rows because there, if you look at the first 4 rows, it's just the, let's say, the license and everything. Here, right? Poppy capture feature of different species. So these first 4 rows I'm skipping. Affiliation to data author, my colleague Daniela Luth, affiliation Rhein University, and so on. And the licenses, so when you want to use the data set, right, you must not change it, you must not use it commercially, and you have to name my colleague Daniela Luth. Creative Commons by non-commercial, I forgot what that is. Anyway, so you can use it, you can redistribute it, but you must not use the data commercially, and you have to name my friend. I find this fair. So then we have now this poppy data set, right? And now it looks like this, right? We have the species name, the capsule length, the capsule width, and so on. Right, and some additional information, so which, basically, that's probably a kind of set, so you have the, because we have basically 5 sets or so she basically distributed them in a box. And, okay, so now we are here extracting 4 of these features, and you can do this by simply calling the column names, then you extract the column names.
Maybe it's important to point out that when you're actually working with pandas, pandas has a really cool feature. If you were working with a regular, for example, NumPy array, it will print all of the cells. So if you have a data frame that has 150 rows, which is the case right now, you will be printing all the 150 rows, and you will be printing all of your features. When you have a lot of data, that's not something that you want. Usually when you want to inspect the data, it's maybe enough if you just look at some of the data above, some of the data below,
Right.
and that's it.
Right.
And when you are actually building pandas, that's what it does
Right.
immediately.
Right.
So it omits all of the cells in between, and it prints out the 5 above and the 5 below.
Right.
And you can even control that as well.
So you could, for example, say, okay, I want to see the first 5 rows by saying head, or let's say the first 3 rows, right? Or I want to see the last 3 rows by tail. And of course, you can use indexing, right? But this is too much now. I don't want to explain the indexing. It's a bit difficult, but you can do everything.
And if you don't say anything, you will just print the first 5 and the last 5, and then the rest it's...
If you just do it like this, it basically makes, it first prints head, and 5 is the default number of rows to be printed, head and tail. So 5 heads, dot dot, right, and 5 tails. Right, so that gives you an overview. Is the structure okay? Are the numbers okay? Is the format okay? Right, as a first access. So then you can access the column names, right? It's these column names here, and you can reduce the data set to these names. And store this and so on. You can filter it, head, and so on. So now the very cool stuff works. So I'm using, which one? So I cut, or I basically extracted only these 4. So here you basically see the core of the classification problem. I give you these 4 numbers, and you have to tell me which variety it is, which species. That is machine learning. You have to train, you have to come up with a complex mathematical model. You have a model which you are training. So that means you use math to somehow combine these numbers, and then you test it. Usually you have a data set here of 150 rows. You use, let's say, 100 rows to train the system, and then you use 50 rows to test the system. So which means you are randomly taking 100 of them. Based on that information and the algorithm, you are training the system, and then you use the 50 rows which have not entered the learning to test whether your algorithm also works for the data which has not been observed or which is unknown to the system. That's for the prediction. This is basically a classification problem in machine learning. That's what we call machine learning. You let the machine learn, in quotation marks, right? And now there is another fantastic library called Seaborn. And Seaborn allows you, this is really high-level, fantastic data plotting, allows you to do pair plots. And look at this. It is really fantastic. What you can see here is we have 4 columns and 4 rows, because we have 4 features. We have the capsule length, we have the capsule width, we have the stalk thickness, and we have the cap diameter. And now you are drawing, for example, let's say here, the capsule width against the capsule length. So this is let's say this is the width of the capsule, and this is the length of the capsule. And the colors are the different species. And you see that these points here and these points here are clustering, which means you have a variety, a species with a low capsule width, which is narrow, but a relatively wide range of capsule, what was it again? Thickness, right? The capsule length, the length. So long variety of length, but a small capsule width. This green points. The green points is the papada dubium. And you see, it's this one. Of course. It's thin, and it has some variety in the length. This is how you would say, this is papada dubium. Cool, and you see it in the data, you can distinguish it in the data. Right? And you see here, papada dubium is thin, small, so the diameter is small, right? But it's relatively long probably, but there are also some shorts, right? And now you have to find it out, and this is just one point. Here, for example, you cannot distinguish the points very well. Maybe here is a cloud. So what you try is to find a way to separate the colors. The colors represent the different species. You want to find a combination of the features such that the separation is best. You say, okay, I want to find when I have this width and this thickness and this capsule or whatever, right? Then it is Pampara XYZ, right? If I have another combination, it's another one.
You have to remember that we're talking about a multidimensional world here. We are talking about 4 dimensions in this case, and therefore putting everything in one graph is very complicated. Usually those correlations and that way to distinguish appears in a correlation of just 2 of the variables. And that's why we kind of do a cross-correlation plot. And the idea is that you see in some of them it's ultra difficult to distinguish, but in one of the plots you could already find at least for one of them, at least for one of them the separation. And that is what allows you to do machine learning. Okay?
Here, for example, blue and orange mixes completely, but if you use these 2 features, they are separated.
Exactly.
Why is this the case? And we come to this. So, and then you have a distribution here, right? You see now how the capsule length varies between the different species. For example, here the red species has a capsule length, right? It's a capsule length which is very short, right? This is the length. It's very short. Most of it have more or less the same length, and it's much shorter than the rest of the stuff.
I think that's also important to explain. What this function is doing, this plot is doing, is plotting scatter plots for those variables that are different. So where you're crossing those different variables, but when you have the same variable in the grid, then what that's doing is a histogram, okay, or some kind of a histogram. So that's why what you get here is actually the occurrence and the value of the variable that you're looking at. That's what you should be looking at the first. So
this is the number, I think.
This is the value and this is the occurrence, exactly. So how many of those?
Yeah, it's a bit misleading because the capsule length is actually here. So you have to maybe you could see it here. The capsule diameter. Where is it? Here. This one, right? So this is the capsule diameter for the 4 varieties, and you see one of them, the yellow one, has this cap, right, which is on top. This cap. That's the biggest, the widest, right? Around 18 millimeters, right? It's very, very large compared to these. And then you could say, okay, they are separating. And what you try is really to separate these curves, right? You have to find a combination such that they do not overlap. Here it's very difficult to distinguish, right? They are behaving relatively similar. Okay, then you can rename columns and so on and do some tweaking and so on. Rename the columns, it's too much to explain. Oh, that's bad. What's that? Specification is wrong. Oh God, what happened here? This is really bad. Oh, let me see.
Maybe because
It's called translate. No, is it? Translate. Woohoo! Okay, translate. That's dangerous. I renamed the function without deleting the old one. Specification.
what happened to you when you're coding, and it's the fact that basically every variable that you create using Anaconda will live there until you delete it. So even if you change the name, that variable was already created. That means you could theoretically still use it, and that can lead to problems. So usually a good way when you're doing deletion and stuff is either you free the variable or you rerun So basically, you interrupt the kernel and rerun all the cells, and that will make already that the variable disappears from your memory.
Unfortunately, I have a problem here. I have to change my environment again because Plotly.
It's not part of the base.
So it just takes 10 minutes and then we stop. Okay. So I forgot. So Plotly is unknown in the standard environment. So I have to go to the other environment where I install Plotly. Sorry for that. So I closed this. I saved it. Right? I did save it. Yes. I close it. I stop here. I change the environment. Now I say conda deactivate.
Activate. You are using the base.
Oh yes, activate. Activate. And my favorite is Geo. I start Jupyter Lab again. And again, right, it connects to localhost 8888 lab. I come to the application, and now I run all cells. And now I want to show you the beauty of Plotly. And this is kind of cooler than Matplotlib. Oh, it's still somewhere here. DF. Here. Ta-da! Because what this now does, it creates a interactive plot. You see the different the species, and here the parameters. So now because I have 4 features.
The name of that library?
Huh?
The name of the library?
Plotly. Plotly. But you find it in the code, right? It's there. Let me zoom out a bit. Control 0. Yes. So you see, I have just 3 features here. Let me execute that again. And you can tweak the plot. It's not really nice, right? So you can even get here the different values for each of these points. Here are the different species, and I can now rotate it, right? And if you look from this side, it looks like a mess, right? They don't separate. And when I turn it around, you see that they are separating. And this is what you do mathematically. You're basically turning your coordinate system.
This library is inside of NumPy.
No, it's Plotly. You have to install it. I forgot to add it to Plotly, but you find it. When you execute the code, you get an error message, and then it tells you which library is missing. And then you have to say conda install -c conda forge Plotly in the environment, right? Again, conda install -c conda forge Plotly. And then you have it.
That's the way that you install any library. So
but you see how cool that is, right?
Inside of Conda Forge, and if you don't find it there, you can just Google the library, and it will tell you in which containers they are, so which collections they are.
And when we install a library, we don't need to reset route.
Yes, you have to.
Only Jupyter, right?
Yes.
You
yes.
have to.
Yeah.
You have, because in order to install the library, you need to basically stop the kernel that you're using right now.
Yeah.
Because otherwise, you could also do it from there.
Yeah.
With it's a
Which is a
mess.
bit a bit ugly.
There is a way to call command lines commands from Jupyter Notebook and from Jupyter Lab, but that makes your code very ugly. Especially when you run it again, it will try to run the library again, and that's not efficient. So usually you just you can even leave it open. Just go to your Anaconda, shut down the process, so with Control-C, and you just download the library. When that's done, you open Jupyter Lab again, and you can simply just update because basically you're connecting to the same host. So you could simply just update the window, the tab, and that should do it.
Yeah, but people have to find their way. So so you see there are some mistakes. So I will update the software on our repository on the wiki, so that when you should download them. So I will correct the errors here, so that you can then basically And here you see here name PLT is not defined, and of course PLT is matplotlib pyplot. So somewhere here I forgot import matplotlib dot pyplot as PLT. So what this now does, and that is super cool, it's a bit ugly, but what we are using here is the scikit-learn machine learning library of Python. There are several, right? But sklearn is one of the most powerful. And we are using, so what we are trying to do here is not very sophisticated. We use k-nearest neighbor classification. It's a standard clustering algorithm. What this algorithm does, k-nearest neighbor, I don't know if you know it, right? What it does is it tries to find the midpoint of all the points which belong to one specific, so we don't really do a transformation of the features. It's really just k-nearest neighbors, right?
That's you're doing a standard scaling there.
It's scaling, yes, okay.
But you can still
But
the same idea.
Yeah, the same idea, right? So what basically is done is, from these clouds, the center is determined, such that they are separated most, right? So on one hand, you want these points to be as close as possible to the center point, and you want the rest of the world to be as far away as possible from that point.
So we are looking for a 3D orthocenter, right?
What are you doing?
We are looking to a 3D orthocenter, right?
You can say you are searching for the center of the point. That's something you can say, right?
Yes.
The k-nearest k-nearest neighbor is a very simple clustering algorithm. It's not very sophisticated, but it's for this purpose it's okay. Right? There are whatever, right? Random forests or
Decision trees.
SVM.
So
Support
that's
machines.
one of many ways to
LVAs.
classify it.
Right. But the nice thing is, right, and you should of course learn the algorithms. Don't just, that's also something, because we have a lot of script kiddies in our classes from India, they know how to program Python, they know how to call the function from scikit-learn, but they don't have a clue on data science. They do not look at the data, they don't interpret the results correctly. They think when they can call these functions here that they do a good job. No, you have to understand what's behind. You have to understand the algorithms. Otherwise, you are quite prone to create crap. You have to know what you're doing. In scikit, it's a bit seducing, right? Because it's so easy to use that you just apply it, and some people just apply it and come to results, but the results are stupid because they did not understand the problem. So, and what we are doing here is basically we are importing train test split. That is, the data is split in a training set and a test set. Let's say of the 150 rows, you're randomly taking 60% for training and 40% for testing. Then we have to basically rescale the numbers, right? It depends, so you should basically use a standard scaler, so everything is basically, the data is then transformed to a standard normal distribution, you could say, right? So then we use this, so there are, you see scikit-learn neighbors from this sub module, we are importing the function k-nearest neighbors classifier. That's the actual algorithm. Then we are importing a confusion matrix that tells you basically how good your prediction was. When I give you, because you know the truth, your test data set, you know what it is, right? And then we are comparing, does the machine predict the right species or not? And you know it. And the confusion matrix tells you how good the matches are. You will see it. So then here you can also use the support vector machines and so on. Unique labels, I forgot what that was. Anyway. And again, the data set. And now you see what you're doing here, you have x train, x test, y train, y test. What is x? X is the features. It's a four-dimensional vector, you can say, right? So you are operating in a four-dimensional vector space. We have seen the diagram, which is just 3 dimensions. I cannot plot more than 3 dimensions. But in fact, we have T, and W, and L, and whatever, D, right? So 4, L, W, T, and D. Length, width, thickness, diameter. These are the 4 features, the 4 numbers. And each of these measurements you make, each of these, you take one specimen, one capsule, and this capsule has 4 specific numbers in L, W, T, and D, and you can think of this being a point in the 4-dimensional space. You have an L-axis, you have a W-axis, you have a T-axis, and somewhere is the D-axis, and you draw one point. And then you can look at the axis, how much D you have, how much T you have, how much W you have. That means each of these measurement sets is just one point in a 4-dimensional vector space. The Y is the species. That is basically what you want to predict, the class. So that means you have the, which means when you go back here, right? You assume that L, W, T, and D for this item, right? This is one specimen, right? One capsule in my set of capsules. It's a somniferum. This one has a length of 26 and a width of 19 and so on. Aha. So now I will go to my coordinate system. L is 26, W is 19, T is 3, and D is 16. 1 point in a 4-dimensional space. And this is the specification. So what you want is, basically, when I give you, and your task is, I give you these numbers, and you have to tell me which species it is. That's the classification problem. And then you take from this data set 60%, you are training your algorithm, and then you test your algorithm by basically the data which you have not used for training, which is unknown to the model. And then you see, does it work or not?
And what you want to achieve then there is to do a division that this area here is going to be your x,
This is x.
and this column here is going to be your y.
Yeah.
So that's one x and y.
So you have a complex function of x. So what you have basically is a complex function f, right, with your vector x for measurements, and that is the y. That's what you want. The question is, this is now in our case k and n, so the k-nearest neighbor classifier, right? Good. And you can do it, and it works pretty well. So again, look at the data. So we need the model train split and so on. Let's go on here a bit further. So x and y are defined. Here we are splitting. Basically the whole data set, and we say the test size is 40% of the data, and we use a random number, basically random seed, to do the random selection. And then you get, so X train and Y train would now have 60% of the data, and X test and Y test 40% of the data. Then you have to scale the data, because the numbers could be completely different, right? Maybe you are comparing, I don't know, the size of this capsule to, I don't know, the size of, I don't know. But it could be completely different scales. I don't know what, I don't know, I don't have an example. Anyway, so that is mean, and then you are training, that's all. So X train is the fit transform. And then the classifier here. Now, here you are defining the classifier, which is k nearest neighbors classifier, with, this is an internal hyperparameter. How many points do we take to determine the center? P is the number of classes you want to have. And you know in advance that we have 4 different species. And therefore, you are searching for 4 clusters. And then the metric is Euclidean, so it's a distance measure to basically determine the center of the best point representing the cloud. And then you just say classifier.fit x train, y train, and that's it.
And the cool thing about it is that basically all of the algorithms that are inside work the same way. So in all of the algorithms that you have inside of scikit-learn, you will have a constructor, which is this part of here. This is the name of the constructor. What goes inside of the constructor are the conditions of the algorithm that you should know when you know a little bit of machine learning. And then all of them, you just call them your object, and you call fit. Give X train, Y train, that's it. So they have very, very similar pipelines in order to build everything.
That's really cool. So this stays the same. So let's say KNN, K nearest neighbor, is not good enough for you, right? You want to use support vector machines or another one.
So you just change.
This stays the same, this stays the same, this stays the same. Here you are determining the classifier, say this is a support vector machine, and starting from here, same. That means you can easily change your models and see which one fits best. And then you can predict, right? Because that's now interesting. You have the test data, you predict. So the test data is the unknown data. You are now feeding this unknown data to the prediction, and you predict which variety, which species it is. And in the end, you have to find out this prediction here, is that the real species or not? Does it match or not?
Just a second. So when you apply fit, what you want to find is this function. So you want to try the mapping. That's when you apply fit. Now, when you apply predict, you're basically just giving a new number, so a new set of x to this new mapping function that we found. And then you will try to find out, okay, what is my y now with this new set of functions.
You're right. So maybe we should change this, right? What we do in the beginning, we have this x train, right? This is given, and we have the y train. That's also given. This is the width, the DLWT, right? It's your x train. And what you're now doing is you're trying to find a function such that works as good as possible. It does not always match, but in most cases it does.
You want to reduce the error.
Right, and this f now has hundreds of parameters, right? So you fiddle around in the model, you're basically fiddling the internal parameters such this fits. And then this is the training. So with the training is finding the f, or the parameters in the f. And then the prediction is basically the test. You are now applying the function which you trained here, which you think is the best function, to the test data set. And what you really get, is of course the predicted y. This is your prediction. And the question is, is this the real y you know from your data? Is the prediction really matching your test data? And that's what you're comparing, right? And this is then your performance. How good does the prediction match the test? And then when you go further down, and a nice way to show this is basically the confusion matrix. And you see on this axis we have the prediction. On this axis we have the true species. And for example, Papaver dubium, this is the predicted species, 32. That it matches in 23 cases the real species. But in one case we predicted Papaver dubium, but in fact it was Papaver roeas. This one. This is what you not want to have. You just want to have the diagonal. Or here, predicted species Papaver orientale. 11 times we really predicted the real value, but in one case we failed. And is there any? There is no perfect match, but it's already pretty good, right? If you look at this, you only have a few ones here. It's kind of okay. But when you read,
and still the algorithm has a lot of potential to improve. Because right now you're actually looking at you see that with this randomization that you did while picking up the data, you find out that here you have 24 samples, while with Papaver-Reduce you actually have only 8 samples. And that might be a problem. I mean, that might be that your data is just have that distribution, but that also might be a problem within the sampling. So you already see there like potential to actually change the way that you're sampling and the way that you're creating your test and sample data.
yeah.
And there are a lot of things that you can actually improve there, and that's what machine learning is about. It's about the engineering of, I mean, I have all that, but how do I actually, what can I do in order to improve my classification?
That's what you can do with Python. And you can let drones fly. I can show it as well.
Embedded systems?
The final video, right? The final video, and then we stop. So we have drones and robots.
So you mean you're using a microcontroller to embed the system?
So basically, it's a tailor drone, and it already has a loose controller. And basically, it's usually it's actually sending all the commands to JavaScript, or is it HTML? I don't remember exactly, but
So
basically.
let me explain it. So Python for microcontrollers, right? You have it.
Yeah, microcontrollers. That's okay.
Raspberry Pi, Linux operating system. Pi stands for Python. And here are our mini drones examples, and what we are doing here is basically, so we have a RISE teller drone, and we are controlling the drone by means of Python. You don't see it here, but you can imagine this as an not really an open API, but it has an API, so you can control it through Wi-Fi. And it's a kind of RESTful API. You're sending commands through this API. It's a kind of RESTful API, so a socket. And you're sending commands to the socket, and we have a wrapper in Python. We wrote a Python class. Why is that interesting? We are combining this with the Jetson Nano computer. This is from NVIDIA. NVIDIA is known for its graphics cards, and you can do all the machine learning stuff on graphics cards very well. And the NVIDIA Jetson is a small box. It costs $200, and it has a GPU, a small GPU inside, which allows you to do video streaming analysis in real time with 25 frames or so. And so what we are doing here is we do image analysis, and we are sending the video stream of the Tello EDU. So the software is really developed by Harley. Harley is the guy from Nicaragua. He's fantastic, really. He's awesome, really awesome. And so we have this. We use it as a flying webcam, you can say. And we are streaming the data to the object detector in the Jetson Nano. That identifies the object and controls the drone to follow it. You can see it here, maybe in the second video. So we let the drone fly, and now it flies from the computer, right? You say, in your Python, it can be even a Jupyter notebook, start. This is the video which is analyzed at the same time. Right? This is an external camera. This is the camera of the drone with the video stream interpreted by the NVIDIA Jetson. And now you see how Elgar moves forth and back, and you see how the drone turns. Right? So maybe you start this again. So it determines the bounding box of known objects. Persons are known. Elgar comes here, right? It's a person, that's the confidence interval. So this is the classification, object detection, right? It's a person, and I'm 80% sure that this is a person. And now it can determine the center of the bounding box and control the drone in Python such that it follows the bounding box, so that this is centered. It follows the person, as you can see, right? And then I hijack it because the biggest bounding box wins. So now I just move in, right? Now I have the bounding box. And now I think I hide hinter claim so that the drone now follows claim. And you see how it nicely follows claim, right? But you can increase the bounding box by just spreading your arms, and that's what Ilya does now. Right? He raises his hands, and then he spreads his arms. Yeah. Anyway, you can watch it on the. So he's covering the whole stream, and then the drone follows him again. And the control is done in Python. It's not very efficient, but it's okay. It works.
It's enough to show it's
No. It's about learning. What we want to learn is basically to search for invasive plant species. So we have a plant which is spreading in Germany currently, and it's poisoning. It causes a lot of trouble for horse breeders and with cattle. Usually the grazing cows avoid this plant, but when you cut the grass to produce fodder, food for the cattle, or you make silage, fermentation of the grass, then it's in the silage, and then the cows digest it, and they can really get severe liver damages, very painful, even they die.
But you're not considering, due to German regulations, to provide this technology to a drone which could directly apply a herbicide, correct?
You could, yes. It's not.
Depends on the herbicide, right?
Yes, it rather depends on the. But here the idea is also when you find
that's great.
when you find the plant, you can apply really
Yes.
a little amount of herbicide.
Very site-specific.
That's what we call precision farming.
Yes.
And then you don't have to
Yeah, that's beautiful.
spray everything, but just kill this particular plant.
That's beautiful.
I don't know if that makes sense, right? But it's good fun. So I stopped recording, right?